Hi, I'm Philip Mann, the Technical Director at Kappler, and today I want to talk about heat and thermal hazard assessment. As we've begun to promote our new Durachem 200 product that you see behind me here, a lot of the questions that we've been receiving have been questions other than how it performs against chemical hazards. Because this product is designed for thermal protection and meets the requirements of NFPA 2112, a lot of the questions involve thermal hazards. So probably the most common question I get is, what is the temperature threshold that this garment or fabric will withstand? And we really need to know a little bit more before we could answer that question. You know, we need to know such things as, what is the source of this heat or thermal hazard? Is it conductive? Is it convective? Is it radiant? You know, if you look at things like hot liquids or steam, they're going to present hazards to you differently than, say, a hot pipe that you might bump up into or brush against. So how those thermal hazards are being presented as challenges will drive our decisions. Now, the Durachem 200 fabric has very good heat transfer performance. However, there are some thermal challenges that would exceed the capability of that fabric. So we now also offer a thermal liner that can be worn underneath the Durachem 200, which then provides us much increased or enhanced performance for heat transfer resistance. So especially when we lay up the Durachem 200 in a thermal liner, we're seeing heat transfer performance values that exceed 30, which is exceptionally good. Again, what we do is we want to compare or look at the heat load that's being presented by that thermal hazard. And then we also want to understand the time associated with the user and how they contact that hazard. And then we can use the Stoll curve, which is designed and created to compare thermal loads and exposure times to predict second-degree burns. We've done a lot of testing. I think the hazard that we've tested to date at the highest temperature level would be a thing called smelt, which is a byproduct of the pulp and paper industry. And users are being exposed to that substance at about 1600 degrees Fahrenheit. So we can take that and look at exposure times, really the time for a user, if exposed, to get to a shower where they can get cooled off after that thermal exposure. And we've seen times up to about 30 seconds that they would be protected and not receive a second-degree burn. So we're again trying to be much smarter about thermal hazards. It's not something that we've looked at or had to deal with over the years. We've primarily been around chemical hazards, but we're learning a lot more. And we're beginning to be able to ask those questions as we interact with the user. So again, that's a little bit about thermal hazard assessment and how our product performs in those situations. I'm Philip Mann, the Technical Director at Kappler.